Let me start recording.
This meeting is being recorded.
All right, how's it going, everyone? So welcome to this demo. Yeah, as I mentioned earlier, my camera's not working for some reason. So the first thing that I'm going to do in order not to see like a black screen, is just share my screen. Good. And I'm gonna, well, first of all, I'm going to explain a little bit on the demo. So let me open. Oh, sorry. My camera is actually working, but it's not showing anything. So I'm just gonna stop my video on Zoom, and now you should be able to see this. Cool. All right. So now at least you can see my face. A little bit weird, but yeah, the demo today is going to consist of this on how to use media pipe just to show different landmarks on my face or on your face if you want to go for it. And yeah, tomorrow, because if I try to make everything today, it's going to take a lot of time. So tomorrow, I'm going to show you how to use this landmarks, the landmarks on your face, to open a Spotify and play a song based on your facial emotions. So if you're happy, you will, in my case, what I'm going to do, if I'm happy or if it detects that I'm happy, it will play a focus playlist. So yeah, whenever I'm happy, I usually go for doing some work. Yeah, that's how we think. And if I'm sad, yeah, let's hear some happy songs, right? So that's what I'm going to do tomorrow. But for now, let's see how to detect emotions based on the landmarks on my face. Let me close this. And if you have already attended to some of my demos, you will know that yeah, MediaPipe is a library that's very easy to use. All the models are already uploaded, and you just need to install that library. And the library will contain models that you can use to make predictions. So once again, let's go to MediaPipe. Let me show you. In this case, what we are going to do is use this face mesh model, and basically, yeah, it will detect 468 different landmarks on your face. Okay, so that's really cool because it will detect a lot of points on your face, and yeah, you can use that to put different images on your face, or you can even think about the deepfake image, deepfake videos that you can see online on people just pretending to be a different person. So well, all of those videos are based on this type of model. And yeah, that's a really cool thing. I'm not going to go through all the theory. You can just you can read the documentation, and you can read the papers based on this model here on this website on the MediaPipe webpage. What I'm going to do is going to show you a little bit on the code that we are going to use. This is going to be basically us with the hand tracking demo that I ran last week. Yeah, this is going to be the same. You can just copy paste it and run it on your computer, and you will see that it's super simple. You don't have to worry about anything. Now, the problem with this is the amount. Well, that's a good thing. The amount of landmarks that you will have, it's a good thing, but at the same time, you don't know what landmark or what index corresponds to each part of your face. It's going to be a little complicated. So let me show you that. What I'm going to do is going to open a new window on VS Code. I'm gonna start a new, oh, sorry, let me, face a core, for example, and I'm gonna start from scratch so you can follow along if you want. Okay, so we have this face AI core folder, and I'm gonna create, yeah, face dot I, oh sorry, iPad, just a notebook. And in this notebook, well, sorry, first of all, I'm gonna activate my kernel, the same one that I used last week, which is named MediaPipe AI Core. and this environment has MediaPipe already installed. And that's everything we need, actually. So I'm gonna copy paste this until the very end of it. And oh, sorry. Here we go. Just gonna paste it. And I'm gonna remove this part that says for static images because I'm gonna use my webcam. Cool. All right, so now I'm just gonna say cv2 dot destroy all windows. This is going to close all the windows showing my camera, showing my image once this finishes running, because otherwise the window will be stuck on the background. Can't open camera by index. Am I using my camera somewhere else? Sorry. Looks like saying that basically I'm using my camera somewhere else, but can't tell which one. Let me use my other camera. Okay, cool. So yeah, this is as simple as this. I just copy paste it, and now I can use the model. But as you can see on my image, all these parts of the image of my face, all these intersections between the grid and the lines and all of that stuff are different landmarks. And it's going to be a little bit difficult to take which one corresponds to what. For example, how do I get to this landmark here? How do I get to this landmark here? How do I get to this landmark here? It's going to be really, really difficult because there are 468 different landmarks, and unfortunately, there's no documentation on the website on how each landmark is labeled. So let's take a look at one of the things that you can see in the code. And this is going to be very similar to what we saw on the hand tracking demo last week. In this case, you can see that we are iterating through all the face landmarks based on the predictions that the model is doing. So first of all, let's see what face landmarks look. Let's see what it looks like. Yeah, so basically it's a bunch of different landmarks, and then basically this for loop here is iterating through all of them and then making the picture or drawing all those landmarks and all the connection between those landmarks. That's basically it. So here we can see that we have the X, Y, and Z coordinates. So we can take a look at those coordinates by saying landmark here, which is an attribute of face landmark. And all right, now it's basically now we have a list with, once again, all the landmarks. But once again, we have like 468 landmarks, and it's going to be really difficult to know what's going on here. So for example, if I want to access landmark 0, it's going to give us like the X, Y, and Z coordinates or landmark 0. But once again, it's very difficult to know which one, what landmark or what index correspond to what landmark. If I just say here X, it's going to give us this value. Okay, so we know that. Let's try to leverage that information and try to make some sort of map that is going to tell me the corresponding index of each landmark. So in this case, sorry, I'll be just coding everything from scratch, but it's going to be a little bit tricky if I want to do that on time. So what I'm going to do here is basically I'm going to take all the X coordinates and all the Y coordinates, all my landmarks. You can see here that I'm using sorry, let me zoom in a little bit and close that here. So basically, we are going to iterate through all the landmarks, and I'm just going to store all the X coordinates in X coord and all the Y coordinates in Y coord. So if I take a look at that, X-chord will look like this. Okay. And if I take a look at Y-chord, it's going to be very similar. But each one of us, X-chord and Y-chord is going to be the collection of X and Y coordinates that we can use to plot the, sorry, let me remove that, which will help us to plot a map of the landmarks with its corresponding index. So we are going to make a zip out of this. And if I run this, let me show you what coordinate would look. Yeah, it's going to be a list of tuples where the first item of each tuple is the X coordinate and the second item is going to be the Y coordinate. Okay, so I'm going to import NumPy, and this is going to be the width and the height of the map that I'm going to plot. Now, if just in case you don't know, CV2, I mean from last week, if you don't know how it works, CV2 is going to plot images that are stored in the form of a NumPy array or any array at all, any array for that matter. So I'm gonna create an array of all zeros. Oh, sorry. I'm gonna create an array of all zeros with this dimensions with 1,440 times 2,240. Cool. So yeah, let's take a look at blank image. Cool. And you can see that basically it's an RGB image, right? Well, it will correspond to some sort of RGB array. But in this case, everything is going to be a zero because if you don't know it, a zero in three zeros in an RGB image correspond to a black image. Okay, so we have our black image put as an array. And now comes the interesting part. So CV2 is going to plot that image and then is going to add some circles and some text on that image. So in this case, what it's going to show is basically one circle for each X coordinate and Y coordinate. And along, well, close to that or the same position is going to put some text corresponding to the to Y, which is going to be, well, the index corresponding to that point. So I'm going to plot that, and you can see here the last image that it took from me. And if I zoom in a little bit, yeah, you can see all the index corresponding to each landmark. It's a little bit, it's a little bit noisy, it's a little bit busy, but if you plot this with different positions on your face, you will eventually get the landmarks that you want to use. Okay, so all right, so now we know how to detect landmarks and how to label each landmark. So what I want to do now is detect my facial emotions. So one thing, or at least one simple thing that I'm going to do is, let me show you an image that I draw myself. I know it looks terrible. I'm not the best drawer. I'm not the best painter ever, but let's imagine that there's are some lips, and if you don't have any sort of facial emotion, you're just serious, so to speak. Yeah, let's imagine that these are going to be the commissures, and this is going to be like the tips, the upper tip and the lower tip of your lips. So imagine that you have a line connecting the upper lip and the lower lip, and the perpendicular line crossing that line on the middle point is going to help us detecting if someone's happy or sad. Because if the commissure, I'm not sure how to pronounce it, commissures of your lips are above that line, that means that you're happy. And if you're sad, yeah, the these 2 points of commissures should be below that line, that perpendicular line. Okay, so yeah, we need to detect these 4 landmarks. And yeah, since I already done this and I don't want to spend a lot of the times, I can tell you that these landmarks correspond to, the upper landmark, the upper lip landmark is the 0, the lower lip is 17, the left commissure is going to 78, and the right commissure is going to be 308. So yeah, we can use those, and we can use those just to detect the facial emotions, as I show you right now with that fantastic drawing. So I'm gonna copy paste this. This is going to be the same code as you saw earlier, the same one that I copied, but in this case, I'm just commenting out all of these drawings that we saw earlier here that will correspond to all the drawings that were basically adding some landmarks and some lines to my face. I'm just gonna remove them, and I'm going to add some circles to my left, right commissures and the upper and lower lips. So as I mentioned earlier, yeah, left commissure is going to be 78, right is going to be 308, and 0 and 17. So you can see that, yeah, I'm basically defining a tuple with the x-axis and the y-axis, and I assign that to each of these 4 variables. And then I'm going to draw a circle at each of those points. Let me comment this out, and if everything works fine, this should be, yeah. You can see that my 2 commissures are, I have like 4 points, 1 at each commissure and 2 on, 1 on the upper lip and 1 on the lower lip. So if as I mentioned earlier, let's say that you want to draw some sort of perpendicular line to the line connecting my upper lip and my lower lip. So yeah, now that's working fine. So now we have to calculate the perpendicular line to this one. Okay, so in order to do that, we need to apply some maths. I'm sorry, I know you wanted to see some demos and some fun stuff, but yeah, not everything is going to be fun. So yeah, we can calculate that very easily. Actually, if we take into account that the middle point is going to be, it can be calculated with the, let's say the mean value of the position of the upper lip and the lower lip. Then with that, we can basically calculate the slope of the line and the, let's say the bias, like the intercept, right? So M is going to be the slope and C is going to be the intercept of the line connecting my upper lip and my lower lip. And now we can calculate the perpendicular line just by taking into account that 2 lines are perpendicular if the product of their slopes is equal to -1. So yeah, basically we can just divide -1. Sorry, we can divide -1 by M, and the intercept can be calculated just applying, like, yeah, let's say the linear regression equation. Well, I mean, it's not a linear regression, but since we are on a data science and AI course, it's easier if I say those type of terms. And yeah, with that equation, we can just calculate the line that should correspond to the perpendicular line to the line of my connecting my upper lip and my lower lip. And yeah, now it's you can see that's working. It's going through the middle point and it's more or less perpendicular. If I move like this, move like that, yeah, there's a line, there's a perpendicular line going just crossing the line connecting my upper lip and my lower lip. Okay, so as I mentioned, if I'm happy, and I'm really sorry about this, but you will see me making some weird faces now just to show you how what it would look like. So if I'm happy, my two commissures should be above this line, and sorry, yeah, and if I'm sad, they should be below that line. So if I'm happy, yeah, you can see that these two commissures are above that line. And if I'm sad, yeah, you can see that those 2 points are below the line. So let's apply some Python just to make some if-else statements. I'm sure you are more than familiar with that. So this is the same code, left commissure, right commissure, blah 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 blah. Up to this point, everything is the same, but now we are implementing a if statement. In this case, instead of just printing happy or sad every single time, I'm just going to print it at every 30th iteration, so it doesn't clutter the standard output. Okay, so every 30 times it's going to calculate. It's going to calculate the respective position of my left commissure. Well, sorry, not the position, the height of my left commissure and my right commissure. So you can see here that is going to be like some sort of prediction of what's supposed to, if let's say that well, actually, let me show you. Let me run this once again, and basically, okay, so basically this left commissure prediction y is going to correspond to the y position, to the height of the line of this, at this same x-axis. Does that make sense? I'm not sure if that's making sense right now. So basically this variable here will correspond to this sorry, I'm making some weird faces, but basically it will correspond to the the y position of corresponding to this x position on the line, if that makes sense. So basically it will be just like projecting my x-axis on the line of my two commissures. So that way we can just we can know if my commissures are above or below the line. Did that make sense?
I'm sorry, how is it using the x-axis? You can tell if it's above or below.
Yeah, so all right, so the thing is that this equation here is basically the same one as you could see. So you know that a linear equation is going to be mx plus 0, right? So this one, the x in this case is going to be the x position of my left commissure, and m is going to be the slope of the perpendicular line. And b in this case is going to be just that intercept that we are calculating constantly. And the same one goes here. So we can calculate the respective y position of that left commissure, but if it were projected on the line.
Okay. In the slope calculation, there is a plus 0.0001. Does that really make a difference?
Oh, no, it doesn't make a difference. Basically, because you don't want to divide anything by 0, because otherwise it will just. Let's say that for some reason my upper lip and my lower lip are at the same x position. Then this will become 0, and Python will throw an error. So in order just to prevent that type of error, I'm just adding a really small term.
Yeah. All right.
Cool. So with that in mind, let's just run this, and let's take a look at the output. Right now, you can see that I'm happy. And if I'm sad, yeah, oh brother, Okay, yeah, I'm sorry. As I said, I'm really sorry, but I'm really sorry that you had to see me making all these weird faces, but at least you can see that it's working. So if these 2 points are above the line, I'm happy. I'm sad. And of course, you don't have to print out or you don't have to put that into the picture. You can just you can just remove all of these lines, and this line as well, and you will see the same result. You will see the same detection, but without all the lines in the image, which can cause a little bit of noise to the image and all that stuff. You can see that now I'm happy, and it's printed I'm happy. If I'm sad, it's printed I'm sad. Cool. Any question? Because damn, 1 minute past 10. I'm sorry about it. I never finish on time, but at least I could finish. At least I could show you everything that I want to show you. Cool. So, any question?
For the rest of the emotions, do you just usually just continue using these numbers and just do an if statement or cases for each emotion, or do you build like a mini classifier out of it?
Well, in this case, it's not classifying because the prediction in this case will consist on detecting your face and drawing or detecting all the landmarks on your face. That's basically the prediction. So, but then we're not doing any sort of predictions once we get all the output from the library. All of these lines here is basically pure Python. And yeah.
I'm talking about like if you want to include more, would you just like is there a data set that already has the emotions so you can just right away like
no, in this case I had to hard code it myself because yeah, I just if for example you are surprised or something like that, then in that case actually let me show my screen. Let me run that. If you're surprised, probably your eyebrows will be raised or something like that. Or if you're angry, your frown will you will frown your eyebrows. So it will depend a lot on what type of emotion you want to detect or you want to take a look at. It in this case, I just use happy and sad because they were more or less easy to detect by the camera and by the landmarks. But yeah, you can do that. You can do as many emotions as you want, as long as you can detect all the landmarks, and as long as you know how to, or as long as you know more or less some sort of threshold that you have to surpass in order to detect, for example, that your eyebrows are more elevated than usual, for example. Okay, does that make sense?
Yeah, I mean, I understand we can do with the threshold and all this. I was just looking for a more elegant way.
Oh well, if you want, actually, if you want an elegant way, I wouldn't suggest to use this because this was just an example on how to use the face mesh library. Actually, it's better if you use face mesh to do this kind of stuff, in which you can just put yourself on glasses or you can put yourself a mask or something like that, because it can detect very easily all the position of your face, all the different position of your face. And this was just an example, because once you know how to do all of this, basically doing different stuff with this library will be much easier, because nowhere in the documentation will tell you how to detect or how to index or sorry, how to label your landmarks. But yeah, once again, if you want a more elegant way to detect different emotions and a quick way, I will go with Teachable Machine, which yeah, I've already run a couple of demos on Teachable Machine, and yeah, you can use as many classes as you want here. You can use happy, sad, angry, and then you can train the model by yourself just by taking picture of yourself with those different emotions.
All right. Yeah. Okay.
If you have any doubt on how to use Teachable Machine, you can just take a look at the demo. I'm not sure if you attended to that one, or just let me know if you need any help with this. But basically, you can just put the name of your emotion here, use your webcam, and start recording yourself. For example, happy or sad, for example. Hello. And yeah, it's very easy to use. It's very easy to use. So if I'm saying happy, but I can just put put a happy face and train a model with that. Or if I want to, put some sad images, I can do the same here. And yeah, if I train the model, you can see that it's going to be super quick. And yeah, that's another thing that I wanted to mention, that usually this face mesh library is not meant to detect different classes. It's basically meant to detect or to be used for detecting different landmarks on your face. So if I'm happy, a thumbs up. Well, more or less you can see that's working fine, and it took almost nothing to get trained. But yeah, once again, I wouldn't recommend Teachable Machine if you want to get some more advanced outputs. It's just for classification, not for segmentation or for object detection. It's only for classification. So yeah, once again, if you want something a little bit more sophisticated, you would be using this media pipe library. If you want something quicker and, as you said, a little bit more elegant, it would be Teachable Machine.
Right.
Yeah.
Thank you.
There we go. Sure thing, no worries. Any other question? Cool. So in that case, just wanted to say that yeah, tomorrow we'll kick off at this point, and I will show you how to use the Spotify API to play happy songs in case it detects that I'm sad, and it will just play some focusing music in case it detects that I'm happy. All right. Cool. If there's no more questions, I'm gonna stop sharing. All right.
Thanks, everyone. That was pretty good.
All right. Thank you. Thanks a lot. I hope the explanations were clear enough, because I found it a little bit difficult to explain like all these slopes and all the perpendicular stuff. But I hope that was clear enough.
Yeah, it was great.
Okay, thanks. Cool. So yeah, I'll see you tomorrow. Tomorrow I'll show you how to use the API, and if you can find a usage to that API apart from doing some silly stuff, that would be great.
Okay. See you then. Thank you.
Okay, see you guys. Cheers.
Cool. Thanks, man. That was fun.
Thank you. Cheers.